All right, so hopefully I've made a good case for context being a cue that gets encoded along with the material. What we find is that context has a bigger effect on your episodic memory more than it does on your semantic memory store. And so as you're learning things in college, you are experiencing episodic memory. This is you'll remember where you read about the testing effect, or you will remember the day in class when a demo happened, or something like that. That's what we call episodic memory. You'll remember the episode when this event occurred. Semantic memory, I've mentioned before, is this big storehouse of all the things that you know, and typically you don't remember how come you know it. You don't remember when you learned it. You don't remember the context of acquiring that information. So it's not surprising that encoding specificity has a bigger effect on episodic memory than it does on your semantic memory. Now, here's a little foreshadowing for you. With episodic memory, as you're learning something new, it's going to be there in that episodic store. But if it's something that you use over and over and over again, and it's something that is part of your training or is important at work or something like that, it'll slowly move over into semantic memory, and you'll kind of forget how you ever knew this in the first place, and it just becomes your semantic memory store. So practice, again, kind of can move information from, effortful, you're aware of when you learned it, that kind of thing, into, sort of automatic, it's no longer tied to context, kind of semantic memory. So types of long-term memory. So we've talked about procedural before, and that is the knowing how kind of memory. Declarative memory is the knowing that. You know that George Washington was the first president. You know that your phone number is whatever it is, right? That's declarative memory. Declarative is made up of your episodic memory. So those are your personally experienced events that you remember the experience. Semantic memory is all your factual knowledge. So declarative is made up of episodic and semantic memory. The likelihood of forgetting under episodic memory is pretty high, whereas semantic memory, it's into this big knowledge base that it's really unlikely that you're going to forget things that are in your semantic memory store. You may have difficulty retrieving it because the cues aren't sufficient or something like that, but it's in there and it could be found given the proper cues. The usefulness of the contents, a lot of times the usefulness of your episodic memory store is not that, it's not that useful. Yeah. The exception that I will give is that the things that you're learning in college oftentimes are very useful to your career and the things that so like you'll remember that you learned that in this class or that class, and then you apply it at work and you're going to say, well, this is pretty useful. But a lot of times our episodic memory store is full of a bunch of like this party or that movie or a bunch of stuff that it's like, it makes our life interesting, but is it all that useful? Whereas the things that are in our semantic memory store have probably moved there because we've used them so often, right? Because we've retrieved that information so often that our brain came to the conclusion, this needs to just be a fact and not something that I need to know about the context, or the context doesn't matter. Anytime I'm retrieving it, the context doesn't matter. It's the fact that matters. And so typically we call the semantic memory store full of high usefulness contents because it wouldn't be there if your brain didn't perceive it as useful. The recollective experience, the experience that you have to actually remember it, tends to be present with episodic memory, where you have to think back about, did I see that movie? Who was I with? When was it? You go through this process of trying to rebuild the memory, whereas with semantic memory contents, you don't necessarily feel like you're having to search through and find it. It's stuff that you just know. Some of it you maybe need to be a little bit kickstarted with, like maybe if I ask you what your phone number was before your current one. For those of us who have moved and stuff like that, what was your previous phone number? At first you might be like, oh my gosh, I don't remember. But if we kickstart you with maybe a couple of digits, all of a sudden you can do the whole chain of it. So sometimes the cues need to be better, but generally you don't have a sense of searching for it and trying to remember. It's just knowledge, and it offers itself usually. Sensory component. Do you have a sights and smells and sounds all sort of incorporated with the memory? Yes, with episodic memories. You can remember whether it was dark or light out. You can remember whether it was warm or cold. You can remember, whether you were happy or sad. You can remember all these things. Whereas with semantic memory, it is a warehouse of facts. So yeah, you don't have a sensory component to it. The presence of emotion, again, yes for the episodic memory and no for the semantic memory. It's sort of just disembodied things that you know. Whereas the episodic memory is full of all the passion or the fear or whatever, you were experiencing at the time, because the context is being encoded along with it. So let's let Frederick illustrate the different memory types. Frederick is in the early stages of Alzheimer's disease. So he is starting to forget like recent things that have happened. But he remembers a lot of things from his younger life. That's really typical of early Alzheimer's. One of the things that he knows about himself is that he loves golf. Now, evidence of episodic memory within golf would be like, where am I trying to hit it? Where's the cup or the flag? How many strokes have I taken to get from the tee to this hole? Those things require episodic memory. Semantic memory would represent like his knowledge of what a birdie is, or I don't play golf, so I'm trying to think of another term that I know. I don't want to just say eagle because that's basically a birdie kind of thing. So I don't want to say that. I want to think of like I'm thinking of that term when you get to do it over again, and I can't think of what it's called. So, that's awful. Mulligan, got it. So he knows what these terms mean, or not. Good strategies for, getting the ball from the tee onto the green in one stroke, those kinds of things, the basic rules of golf. All of these things would be semantic memories, because these are things that he's done across his lifetime playing golf. And so he doesn't even remember when he learned the rules. He just knows what they are, right? That would be a semantic memory store. And of course, there's also procedural memory going on here, which is all the physical stuff, right? Like how to do the swing correctly and where, when to rotate his hips and all these things. So his procedural stuff was all intact. His strokes, his swings were all what they normally would be. He used golf terms appropriately and spontaneously, implying that he wasn't searching his memory to find his old semantic memory store for the terms like I just did, trying to remember the word mulligan. These are things that were just easily retrievable for him. And so he had his semantic memory store in place. He remembered all the rules. He knew what strategies to employ. Where he had difficulty was, whose turn is it, right? He forgot that this group had played together last week, right? Like the things that were specific episodic memories is where he had deficits. And that's what we see oftentimes with the progression of Alzheimer's, is that the first to go is the episodic memory. What tends to be preserved is the semantic and the procedural. Ultimately, those start to decline also as Alzheimer's progresses, because it is a progressive disease. But in the early stages, this is kind of how you can kind of tell that a person is probably having some kind of I'm thinking of multi-infarct dementia, something like that. They're having some kind of dementia, is that they're having difficulty with episodic memory. That's usually the biggest symptom of dementia. So we can definitely see that episodic memory is the first to be affected in these kinds of dementias. So let's talk a little bit about the processes that can be used to retrieve information. One way to retrieve information is what we call the generation recognition model. That idea is that when you're trying to retrieve information that you believe you have stored in your memory, you're going to generate possible responses and then recognize the correct one from whatever your brain has offered, right? So you pull out a bunch of things and then you go, yeah, that's the one I'm looking for. This is the kind of retrieval that is used in recall tests. If you're taking an essay exam, for example, and you're asked to describe the generation recognition model, you're going to have to come up with, oh gosh, I was taught so many different models in this class. I'm going to have to go, is it the encoding specificity model and, its definition? Is it, this definition of the generation effect that I've got memorized? Or is it this other one that is where you generate possible responses and recognize the correct one? Oh yeah, I think it's that one, right? Like that's what you kind of have to do in an essay exam. And that's why a lot of times when I give essay exams, I see students sort of like looking up and to the right as they're trying to go through their different possible alternative answers that they think might apply to this prompt. So recall tests like essay tests are a good example. Recall tests like the ones that you've been taking in this chapter where I'm reading you a list of words and you're supposed to write down as many as you can recall in any order. That's a recall test. And you have to sort of generate words and decide, was that on this list or not? Right? Like, is this part of the list? The single process model says that we generate possible responses. We don't judge whether they're correct or not. And we use this kind of approach when we're doing recognition tests, like multiple choice tests. We don't have to we don't have to decide whether the responses are correct or not. We just have to recognize the item from the list of options. Cued recall is where we oftentimes will give you, like I gave you the category, and you were supposed to respond with the category member. That's cued recall. That's a single process model task. And then rapid relearning is another single process model task where let's say you've taken a foreign language when you were in high school. And then now, years have passed and you're supposed to fulfill the language requirement for your degree. And, your high school stuff's going to count as 1 year, one of the required entities. I don't know what to call it, time periods. But you have to do one more quarter to fulfill it. And you're like, man, but I don't remember anything from the year I took in high school. Maybe I should just retake both of them. So you take you take the first one in the sequence, and which is supposed to be, analogous to the 1 year you took in high school. And you're like, holy cow, I do remember this. I do remember my alphabet. I do know the present tense conjugations or whatever. Learning it much faster the second time is evidence that you had it in your memory. And that's thought to be a single process model where you're just sort of recognizing the information. So what we're seeing here in this graph is a forgetting curve. I don't know, it's a straight line, so I don't think the curve is the right word for that. But so on the bottom we have the number of repetitions of the list of words on day 1. And so you see between 0 and 25 minutes to relearn the list on day 2. So if you had on day 1, closer to the left side, the number of repetitions, so it's going to be something smaller. They didn't label this graph on the x-axis, I'm just now noticing. So if you had fewer, you're closer to the left, you had fewer repetitions on day 1, it's going to take more minutes on day 2 to relearn that list, right? Closer to 20 minutes on day 2. Whereas if you're closer to the right side on the x-axis, so you had more repetitions of the list on day 1, it's going to take you fewer minutes to relearn the list on day 2. That's evidence of rapid relearning, and it shows you that the material was still in the person's memory. Maybe they couldn't generate it and then recognize the correct options in a recall test, but they could display rapid relearning. Let's think about that self-reference task that you did way at the beginning of this chapter, where you were supposed to mark off whether the adjective described you or not. And then you generated, you did a free recall task where you wrote down as many of the items as you could in any order. And then I showed you the list and you were supposed to recognize the items now, right? That was it was easier to recognize the items that were present on the list than it was to generate them out of your memory, wasn't it? That single process is a lot simpler in in the sense of like how much effort it takes, right? It's a lot less cognitive effort to recognize the possible options or to recall the option with proper cues or to rapidly relearn the material the second time. Like that takes less cognitive effort than we experience when we're asked to generate the possible responses and then recognize the correct one in the form of like a free recall test or something like that. And I think most people who take both kinds of tests would really agree that the strict recall tests are much harder. They feel more, and by harder I don't mean like higher probability of being wrong. I mean harder as in like I put in a lot more effort into that than if I'm doing a multiple choice test or cued recall test might be a fill in the blank kind of question. Or if we just measured how fast you could relearn the skills as wouldn't that be a fun test to take? I just teach it to you again and see if you learn it faster the second time. Well, that would be hard to do. I don't know how I would implement a test like that in a psychology class. I just thought of that. That would be an interesting design. All right. I'm going to stop here and then we will come back and we will talk about this pitcher who beamed a batter and use it as an example of memory error. So I will see you in the next segment.